Hi, everyone. Thank you for joining my session today. My name is Rawan Al-Adawi, and I would like to thank also Wonder Workshop for accepting me to present at the International STEAM Summit. This is my second time here, and I'm happy to be here and share my experience. My session's title today is Spice Up Your Math Class with Game Design in Scratch. We're going to have fun and learn and explore many ways of how to use Scratch in your classroom, particularly in mathematics, and how to also embed other platforms as well. At the beginning, I would like to give you an idea about what is my experience. I have more than 10 years of teaching experience, and mainly in ICT. I taught in 4 different countries and a lot of international schools. I collected so many badges. Recently, I'm working on my ISTE certification. I'm an ICT teacher as a title and a NetTech trainer as a freelancer. You can see my links here to connect with me on social media. I have a website as well, and there are my emails at the bottom. So today's session, we're going to start with a little introduction to trigger some questions in our minds. And then we're going to look at international standards and framework. Then we're going to look at what is Scratch and how we can use it with which age groups and what skills can Scratch promote. After that, we're going to see how math problems can be solved through game design in Scratch and how we can also use flowcharts and other resources to help us break down problems and later on transfer them into games on Scratch. At the end, we're going to look at the design thinking process and how it is important for differentiation and a lot of points. And we're going to see that there are other programs as well that you can use to approach mathematical concepts. And of course, we will wrap things up with resources and other things. So as a beginning, I wanted to look at this diagram that shows the different generations on this timeline. I belong to the millennials generation, which is Generation Y. And I'm currently teaching Generation Z and A. And I added to this diagram or to this timeline a new generation, which I don't know what would be the letter for it. But I think there will be a new generation right here that arose due to the huge exposure to AI technology and the widespread of generative AI, ChatGPT. I think it's a change of an era that we are witnessing nowadays. So going from there, we start thinking, how can we modify our lessons to build on the students' interest from these generations or from the upcoming generations that we don't know what are the letters for them yet? And from here, we think, what interests this generation that we currently teach? And of course, you would directly think about the social media platforms or the games that they are playing nowadays, and a lot of other tools. Like nowadays, every student was born digital. So how can you prepare this generation for the future? And of course, you want to start thinking about skills, game design, app design, because this is where the future is heading. You want to start thinking about coding skills, thinking like computer scientists. Definitely, we're trying to teach how to think like computer scientists because everybody is going digital, or probably the future includes a lot of technology and we want to know how to maintain that or how to make it progress or make it beneficial for us. So we want to help our students also become creators and not consumers, not just consumers. And this is a theory. And definitely something that I always promote for, which is computational thinking skills, which I think would change the way you think or the way you approach problems if you start practicing it within your teaching and also solving problems in real life situations. So When we're thinking about mathematics, directly you think about coding skills. Or when you're thinking about coding skills, you are going to use mathematics. And coming from an experience who I was a math teacher before, now teaching ICT and coding, I use a lot of mathematics in it. And I start wishing, why didn't I learn mathematics in that way in game design? Because it makes more sense to me. And yeah, of course, when we're talking about big, higher order thinking of skills, you want to start thinking about international standards. And yeah, I advocate for the ISTE standards for computational thinking, for the ISTE standards for students, or the SISTA standards for computer science, and mainly the computational thinking skills, which are well needed for the future. And a lot of teachers need to be exposed to those skills and to practice how to use them and how to teach them. Then we stop at the World Economic Forum's education framework, which has been recently released and including a lot of content that we should be including in our teaching practice and the experiences that we need to prepare for our students. You would find big titles such as innovation and creativity, technology skills, global citizenship, and also here you are looking at self-paced learning, problem-based, lifelong student-driven learning, and so on. Moving from there, the taxonomy highlights a high level of abilities and skills, but also highlights as well attitudes and values. And then you have the knowledge at the bottom. If you dive deeper into that taxonomy, you would find that the top 4 skills are creativity, critical thinking, digital skills and programming, and problem solving. Where are we in education? So think about it in that sense. Are we helping our students develop those skills to meet such high taxonomies in education? And then, of course, you want to look at our practice. So when we're looking at game design or gaming apps that we use, how we design them, yes, we are tackling so many of these skills, a lot of them, and some attitudes. I have here creativity, digital skills, but look at this one, which is grit. And I have witnessed this when I taught my students how to develop games. Grit is a very important attitude that the student can build or develop while working on problem-based projects. And in coding skills, you get a lot of bugs or problems in your code and you want to debug them. You want to fix your problem, fix your game, and make it perfect. You develop that resilience and eventually that grit to know how to fix it, and then to become very persistent and to make sure that you're going to get there. So yeah, I asked ChatGPT, which is the latest, of course, ChatGPT 4, how can teaching game design using Scratch meet the Education 4 taxonomy that was released recently? And it showed me so many ways. So I put in bold some of the words that you could see. So you have skill-based, lifelong learning, you have programming concepts, storytelling, math, science and arts, interdisciplinary learning, collaborative environment, and technology integration for sure. It's a highly customizable platform. So now let's pause a little bit. What is Scratch? So some people might be beginners to this or probably learning about it for the first time. Scratch is a purely educational platform. It's for free and it has a curriculum. It has some resources that you can find as well. It has a large coding community where everybody can contribute with games that they design. and you can remix and share games with others. It's available in 70 languages, and that has helped me a lot for the past couple of years, particularly teaching in international schools. You encounter so many nationalities, and not a lot of them are English speakers. So in Scratch, I am very flexible with the students to change the language to their native. Some of them use the Korean, some of them use the Russian, some of them use Arabic, Persian, and yeah, it's been going well. So you have two different versions. You have this junior version, which is what we use with grade, you could say preschool, kindergarten, up to grade 2. And then we introduce from grade 2, at the end of grade 2 and above, you start introducing the real Scratch platform, which can be installed on the computer, but there's also the online version, which helps you share your work with the community and contribute more. So more information over here. This is the online platform, and you could see there are featured projects by other students, people from the community. So Scratch definitely promotes computational thinking skills, critical thinking, problem solving, programming, logical reasoning, and math. But also I made sure to put grit for you because definitely you will sense that. And design thinking. Design thinking is the really important point in it. So now let's show you how Scratch works with math problems. Here's a typical math problem about calculating the cost for the number of seats that you could use. So you could give a word problem like this one to your students and tell them that for one seat, the price is 230, let's say. But if you take more than 3 seats, you're going to get a lower price, so you have a discount here. So imagine you have these conditions and you want your students to develop a mathematical problem in that, to solve it, and try to find the cost for any number that you give it. That's how you design a game, basically. So to translate that word problem, we start thinking about the scenarios in it. And of course, we're going to use flowcharts because flowcharts help the students understand the problem and break it down, decompose it, which is particularly one of the aspects in computational thinking, decomposition. So you're going to start breaking down the problem. You're going to have an input of what is the number of seats. Then after that, you are going to have scenarios, which are the conditionals in that case. And when you teach the students how to design a flowchart, you must tell them what each symbol means. Like the if are conditionals, that's why we put them in a rhombus. Whereas the input and output should always be in a parallelogram. And this helps them a lot later on when they're transferring that flowchart into a code on Scratch. So moving on from there, you got the cost, which is you use variables for it, of course. And imagine students from grade 3 learning what a variable is and how to use it in game design. How easy is it going to be for them later on in grade 7 and 8 when they are solving algebra problems, including variables? It will make more sense to them. So yeah, thinking about the cost, so you would see we have 200 here if it's more than 3, and then the other rules over here. And at the end, you have the output, which is the cost, and the end of the problem. So how does this translate to a code? Here we go. So imagine the first one you start, you need a trigger in your game. So we put, for example, the green flag. After that, for example, the input, you must be using the sensing blocks, and you could see that there are different colors for every type of a block. Then the conditionals with the variables. So for each condition, if it's bigger than 3, We set up a variable for total cost. We get the answer, which is the input, multiplied by the exact number we want. And you get the 3 different scenarios inside each other using an if-else block. And at the end, you want to put something to display your message. So you can display it through a speech bubble, for example. And you display your variable over here, which is the output. So this was one of the problems that you could solve using Scratch. I'm going to take you on a tour over different scenarios, different math problems that I solved with my students. You could say from grade 5 up to grade 7. And I also used some of them with grade 3 students. So let's have a look. This is the cost of a call. This was the word problem. This is a scenario since last year. It's a word problem where you have a telephone company and it charges you money based on the count of minutes that you're talking. And this was one of the codes from the students. And you are going to notice that there is a huge difference between different programs that the students make, because the students will become creative and they will add many more blocks to animate their characters and to show a good animation in the game, to make it more fun or more appealing. So you could see over here, the student designed a really nice background and a character. And you could see in the code that there are so many additional things, but the main code remains really visible, which is the bigger one. So in this project, the student learned what is input, compare values, define variables, and so on until you get an output. I'm going to take you a little bit on this project to have a look at it. I will play it first for you, and let's have a look. How long was the call in minutes? Let's say 6. Post is 300 cents. So imagine the student added to this sound effect some little animation to get to the result, which is something I did not tell them to do, but she wanted to become more creative. And this is exactly what we're trying to push for. Creativity, innovation. What else? Computational thinking skills. Definitely, you're solving a problem, you're decomposing it and trying to figure out the solution for it. And you're building an algorithm for that. Definitely, you applied computational thinking. Critical thinking. Definitely, you are fixing the bugs in your code at some point. I mean, we tackled so many skills in just one project. And this is what I'm trying to tell you about. So going over from here, so this is the project, and this was a word problem as well. I was collecting the word problems from different resources, and the students would solve them. This is the code for a student, and these are the set of skills that he learned about. So in this one, you could see there's a long script that the student developed, which is not something easy to do. But of course, when the students discover how to decompose a problem and try to fix it or try to build the steps to solve it, it will make more sense to them. And because they are building a game, that's why they are capable of doing such a long code, because they have that resilience, they have that grit, that curiosity to finish that game and let others play it. This is the code, a very huge one. All of these are animation effects that are additional. The student added them, personal effort. And this is the main code that we wanted to see as a response to this word problem in math. And of course, I can play it for you. So Greetings, would you like something to eat or drink? So it's an animation still. And he gave me the password as well. And then the animation continues. So this is all still just animation from the student. And now I need to answer the problem. Let's say 2 hours, for example. Your cost in currency is 12, for example. And he gave me the money. Calculate the code, which is also one of the projects that were really nice. But this time we are introducing something called pseudocode. The pseudocode is a different manner or different way of writing a word problem, but in a way that it makes more sense to build the code later on. You could see that there are steps over here that can help me build an algorithm following them, because it's a simplified method of writing the word problem. And we use pseudocodes a lot in computer science. And yeah, this is what I was trying to teach the students, that you could use a pseudocode to represent a word problem and then transfer it to a code. So not all the time a flowchart. So, or you can write a flowchart in a pseudocode mode, then transfer it to a Scratch problem. In that sense, we are teaching math problems, but at the same time, we are incorporating computer science skills and basic concepts in computer science, which what the students need to know now that we are in the 21st century, where we have AI around us and we have games arising, AI tools, generative AI, and so on. So yeah, this is the code. In that game, the students were looking at the length, the width, the area of a room, the cost, deposit money, and the balance. So many variables, 6 variables in just one project. And how to solve the math problem. And of course, the code is right here. And the set of skills is on the right. Another scenario to show you. Create a list of multiples. Understanding what multiples are and how we can create a list of them is really phenomenal. So here I needed them to design a program to display the first 12 multiples of a number through a game in Scratch. And of course, we explored a new tool here, which is the lists tool. So define a list and you make rules for that list. So you start with a certain number, you pick a number, and then you set the multiple to 1, and then you keep adding 1 by 1 and multiply it by it. That's how you make a multiple. So this is one project by a student, and this is the other project by my other student. You could see that there's a lot of animation in this one too. So I'm going to take you on one of them to have a look at it. So the project starts right here. I'm going to press on the green flag and she's going to ask me for the number. So what number? I'm going to say, for example, 6. The animation is purely the student work. Amazing work. And these are the multiples. If I want to play it again, I can just press here. Let me give her a high number, 987, for example. It's going to work, of course, because it's just 9. All right. Amazing. So yeah, these are the set of skills on the right. You have defining variables, list multiples, multiplication, input, and output, of course. And then to create a basic calculator, that is a challenge, and it's not really a hard one. It's an easy task. You might think it's hard because it's a long script, but it's an easy one on the students. So yeah, it's a really straightforward problem. Create a simple calculator, they need to think about the 4 operations, plus, minus, divide, and times. And there are different scenarios in it. And you would see the problems that the students have created here already. So I'll take you on one of them, just a quick tour. So this is the code. And you would see from the code, you've got the animation part, which is in purple, and displaying the answer. If it's plus, it's going to add the 2 variables together. If it's minus, it's going to do that. But how do we know? You ask for X, you ask for Y, and then you ask the person to type one of these symbols, and then you get the response. So this is really amazing work done by my students. And these are the set of skills or the set of topics that we tackled in this project. So drawing polygons, this is when it gets more interesting, when we're moving to geometry and doing arts with coding and mathematics at the same time. So you want the students to draw a certain polygon. Ask them to create a game on Scratch to define the polygon that you want, and then the character will draw it for you. So this is the project that was made by a student, where they define what sort of polygon we want, and they make a drawing of it. These are amazing tools. Now, I can't show you everything, so I put the links in the presentation. So please make sure to download the PDF of this presentation to have a look at these projects. There are also other resources. So it is very important that you access the PDF that I attached with this talk. So flowcharts and other resources. So of course, decomposing problems with flowcharts happens all the time. So to do that, to help you do that, you can help the students develop their own flowcharts using online platforms. And I used so many of them. Visio is an Office 365 application that you can use, but you can also use Google Slides. I mean, there are many applications that you can use to help the students develop flowcharts to decompose problems. And I also developed a full page of Scratch problems on my website. So this is my website. And you've got the topics over here, and you skim through. Now, for example, comparing numbers. You press on it, it takes you to the link. This is comparing numbers. You can download the worksheet. The worksheet is right here. It includes the code, a word problem, questions about it, and the word problem is here. And then you have the game. So this is a project that I made as a sample. So there's the game to play it related to comparing numbers. You can play it over here, or you can click and open it in a new page. So for example, the basic calculator, as I showed you, there's the steps to make it, and with the sample over here. The list of multiples also, this how to make it, and here. And you've got also working with variables. You could have a pseudocode. Then you have how to solve the flowchart of that pseudocode. And like at the beginning, of course, the pseudocode is the word problem. And I put for you the IO Draw, which is a resource to draw the flowchart. You can use it. It's a website. It's a free one. And then the Scratch project. This is the code. This is the project that I made. Below, there are plenty of resources. I used them for my teaching, but I also included them on my website to benefit other teachers. So I definitely encourage you to do it. This sample of flowchart is literally made by my students. So we developed them together, we use them. So that's how I built my resource over here. So of course, my students take huge credit helping me develop this amazing place. So this is one of the areas. It's time to talk about the design thinking process. So I myself use the design thinking process that ends with test and starts with empathize. There are so many other models. There's the shorter one and the longer one based on your need or on your audience. You can find so many resources online. There's an online course for it. There's a video. The design thinking process is an important step in game design. It puts the user experience at the center and lets the student develop a game that works for his audience and to improve it and work on it. So let me take you a little bit on a tour over here.
Design thinking is a 5-step.
I'm going to skip the video. Before design thinking, when we used to develop games on Scratch for one single topic, of course, they would have the same code. So you would find same topics over here, but only different backgrounds and characters. And I wanted to see more innovation from my students. The same thing happened when we did the basic calculator project. So then I started thinking outside the box. What if I give them a challenge to build their own game and think about it, and then work towards achieving that goal that they have? Definitely, there will be a variety of projects, and they will learn variety of skills. So at first, we reflected on our practice designing the basic calculator, following the stages in the design thinking process. And I added another step at the end, which is improve. I wanted them to swap iPads, test each other's calculators, and give feedback so that they improve their work. Eventually, I gave them a template and I asked them, let's plan for a game of your choice, builds on your interest, and let's build it, let's program it. So the design thinking process helped me structure the task and have them pause and think about the user experience, not to mention also the coding part, which was eventually they discovered that it's not easy to program a game. They need to be very specific about the ideas they want to put in that template. And of course, we completed this template over 4 weeks. We revisited it and added to it every now and then. At the end, we ended up with a variety of games. I have so many others. I included 6 of them. Different ideas, different problems, different code blocks, from complex to easy, but you've got games differentiated, all by the students. I was just facilitating the whole process. This is all their work. So, and using Scratch and game design in Scratch allows the students to use a lot of math skills. And I really encourage that you incorporate it. You could be using coordinates to move the sprites. The sprites mean the characters. You could be using angles, operators, performing operations, and variables. Amongst the codes that we did even or odd numbers. We talked about the remainder of a division. If it's 0, then it's an even number or else. And there's other codes that we did that included a lot of math and variables. When we did the polygons and how to draw them, we had to create variables for the length and width, thinking about the supplementary angles because we need to turn and draw. It was a good practice. And calculating costs, of course. So there are so many resources that you can find online to teach Scratch and to include it not just for math, but other subjects too. In other programs, you might be using MSW Logo, which I'm sure like you heard of it. It's old, I know, it's rigid, yeah, I know, but it teaches algorithms and how to use angles to solve problems. The Cambridge curriculum uses MSW logo in their starter's book. And you could use procedures in MSW logo to teach a repeat function and create patterns. There are other tools. Code.org is a nice website that you can use. It's completely free as well. It teaches coding skills, but at the same time, you have the game lab and the app lab where you can create things and patterns in it. There's also Tinkercad Coder Blocks. What's better than 3D design? Automating it, of course. So you can automate 3D design using Coder Blocks here. And Silent Teacher is one of my favorites. Every year during the Hour of Code event, I have my students complete the Silent Teacher. It helps them understand what is variables and how to use them in math, technically learning computer science concepts as well. So the links are there. Make sure to download my PDF for this presentation. It includes all the links you need. So to wrap up, game design allows the students to develop so many creative and innovative and higher order of thinking skills. So ask yourself, to what extent at the moment your lessons and your activities are meeting the international standards that we must use for technology integration or to teach skills and aptitudes for the future. And that's it for me. Thank you everybody for joining my session. These are the resources, and you can still connect with me on social media, on my website, or by email.